So thank you all for coming. My name is Rob Ross. I'm the Associate Director for Outreach at the Paleontological Research Institution. If you're just joining us and you're accustomed to seeing Don in this chair, Don Haas is just returning from a Science in the Virtual Pub. Sorry, that's not right. He is just returning from the American Geophysical Union conference in San Francisco. He would normally be hosting Science in the Virtual Pub, but he is on an airplane as we speak. So I'm filling his shoes this evening and also doing the talk. So with no further ado, it is now our starting time, and I'll get started. And I'm going to tell you about a project that is very much in progress. So and it is a project that involves dozens of people, and so I am just one of them, and I may or may not be able to answer technical questions about some of the things that I discussed this evening, but I can tell you who to go to. So this project is connected to something that we've been doing for many years in our education program, which is try to get people connected to their outdoor environments. And of course, the ideal thing to do is to get people outside, to do stuff, to learn about science and to learn about how we know about Earth history. But we all know that sometimes that's not possible, and none of us can go every place. So we began working on a category of outreach called virtual fieldwork experiences. And the idea is to, when possible, connect people to outdoor environments through some kind of visually rich medium, not to replace doing fieldwork, but as a complement to fieldwork, maybe even involve the participants in creating the virtual field experiences. And but in some cases, maybe they'll never go to the place that we're seeing virtually, but at least it's better than just seeing a picture in a textbook or a single picture on the internet or just reading about it. So in thinking about what would good virtual fieldwork experiences look like, we began to work with teachers on creating such VFEs, as we call them for short. And our goal was to have teachers creating these for their own classes, maybe even in their own neighborhoods, maybe again in collaboration with their own students. But other opportunities arose to create VFEs ourselves for some special projects, for some places that our students couldn't necessarily go to, maybe even places that would be off limit to the general public. So I'm going to share my screen and tell you a story in 3 parts. And the first part is going to be just a little bit of background about virtual fieldwork experiences for those for whom this is kind of a new idea. Some of you may know a lot already, but for some of you, maybe you haven't thought much about it. Then I'll show you an example of one of these kind of special projects that we worked on and have more or less finished, and then tell you about this one that we're actually working on that has to do with the special topic of, and I will share that with you now, the extinction of the dinosaurs. Well, in fact, I won't be saying very much about dinosaurs this evening, but I will be talking about a little bit about the event at the end of the Cretaceous. So I should tell you that please feel free to just shout out if you have a question. I can take some questions at the end, but you're welcome to ask questions or make comments or suggestions as we go along. I may not be able to easily see the chat box, so if you have something that you want me to know, don't hesitate to interrupt. As you know, these are intended to be very informal, and some of you, I suspect, are sitting there with a beer or a glass of wine and just being laid back as you hear about this project. So I will start by saying that even the part that I'll focus on, which is this virtual fieldwork experience for visiting field sites from the late Cretaceous and early Paleogene periods, has been done with other people. So there's a picture of Don with his famous 2x4. If you don't know why it's famous, we can talk about that later. The guy to the right is Richard Gutierrez. He is an undergraduate at Cornell University and has done a lot of work helping to get this off the ground in writing content. And Elena Brion is also graduated and is looking for graduate school right now. She is at Eckerd College and is looking for an opportunity to do some kind of marine science right now. So all of us have been working on this, plus a cast of dozens of people actually doing the research. And of course, for those of you who have been funded, you know that it's important to recognize where your funding came from. This has been funded by the National Science Foundation in several different ways. We had a grant from NSF for a number of years to help us, especially Don, to work on the pedagogical basis for virtual fieldwork. And then that's sort of the part one of this presentation. The second part is funded by NSF that funds a big collections project that is research collections of fossils. And I'll describe that more in a little while. And then finally, the third part is the work that we're doing right now. Okay, so virtual field experiences or field trips, as they're maybe more traditionally called. These serve many different purposes. I've already described what they are, but you can imagine that anything that simply shows you a place that you haven't been to is in some sense expanding the realm of your knowledge. And so that could mean, for example, somebody asks, could I make my presentation full screen? Yes, I will try to do that. The reason that I didn't make it full screen is because I have my I have an old laptop and sometimes it gets slow when I go to slide show mode, but I will give it a try. Okay. So so these can serve a variety of purposes. Something perhaps as simple as a series of images or photographs. This one, I think, from the 19th century in the Grand Canyon. No one would call this a virtual field trip, but some of the first times that I heard people talking about virtual field trips was in the context of the first few years of the internet, when people were putting on photographs of field sites. And I guess the primary difference between that and books of photographs was that they were hyperlinked and you could move from one to the next in ways that weren't just linear. But it was still basically a slideshow. And in any case, we've been thinking for a long time, we being people that want to share geology, about how to do this in ways that communicates with people who may not have firsthand experiences. This is a lovely old image of the strata of the Grand Canyon. And of course, this was, the art of high technology at one time, right? These stereoscopic images where you could use a special viewer to see this in 3 dimensions. I promise not to show many boring images like this one, but I tried to map out what I have in mind on this 2-dimensional diagram. Along one axis at the bottom is a range from passive to active. We really want people to be active to learn, but we know that sometimes that's not possible. And then they range, of course, from low tech to high tech. And high tech isn't always better, but sometimes it does enable us to do things that, and actually for people to be more active than they would be otherwise. So in some sense, the the simplest thing is images that we just look at, and at some level, maybe the most active thing would be using these three-dimensional goggles, like over on the right-hand side here, to actually sort of imagine that you're out in the field and picking up specimens and so on. This is out of both in terms of cost and complexity, out of the range of most people today. Maybe someday it'll become more common. It's still nothing like being there, but it's important for somebody to see to see how far we can go with these kinds of tools. However, of course, the kind of the mother of all virtual fieldwork experiences is actually doing the science through the virtual experience. So when we went to Mars with Mars rovers, we weren't there, but we could take images and actually do the science and be active in that sense. And so that's sort of at the far end of what's possible through doing these kinds of virtual experiences when you really truly can't go there. When we were in the process of developing the methods behind virtual fieldwork, and of course, it's the case that many, many people have been working on virtual fieldwork experiences for many years. They exploded during COVID, but they had been a thing for the previous 2 decades. But we have tried to compile some of the pedagogical ideas behind it and some of the tools, at least low-cost tools that you might use in making them, and how they might be used in the classroom, and then actually create a catalog of virtual fieldwork experiences that we've created and other people have created, and some of them are more passive and some of them are more extravagant. And so I'll show you that in a moment if you're interested in going there. And so one of those gold bars, there are links on this is the Earth at Home website, takes you to a page where you can see some case examples. And so I'm going to show you just an example of a virtual fieldwork experience, not necessarily the best or the most pedagogically effective, but if you're not familiar with VFEs, this will give you a sense of what I'm talking about. So this complicated looking image is just to remind me to say that this is the group of natural history museums who work together on a project to compile a database of all of the fossil specimens that had been collected along the Pacific coast of the Americas, primarily North America, but also South, and in order to basically for research on the evolution and extinction of these faunas. They're specifically on Cenozoic invertebrates, and the acronym is EPIC. So when you hear that EPIC acronym, it just refers to this project. PRI is a part of that. Even though we're not on the West Coast, we do have some excellent West Coast collections. And Don and I worked with colleagues from Berkeley on this. And we created a website with EPIC virtual field experiences. And the idea behind this was to take people to sites that are famous for the abundance and diversity of their fossil faunas that are now in these museum collections, and the basis for a lot of what we think we know about evolution of marine diversity in that area, to enable people to visit these sites. Because although a couple of them are public, some of them are off limits, and even if you could go to it, it's far away if you're on the East Coast, and so you might never get a chance to go there. So our hope was to give people a window in on what these sites are like, and also to create something that might be useful for educators. And so this is our team. There's Don, and Lisa is the head of education for Berkeley, and Jessica and Erica are our colleagues on this project also at Berkeley. And of course, that's me. So in thinking about how to create a virtual field experience that would be interesting and educationally effective, we wanted to organize it around some kind of engaging question. So and I'm sorry, I'm looking at one of the chats here. Question from Bob Mosier: what software app is being used to map the data on the specimen locations, ArcGIS? I actually don't know. So I assume that you're talking about the research data from the museums. I think probably, but I actually was not involved in that work, so I'm afraid I don't know the answer to that question. However, sort of maybe perhaps by coincidence, we are using the tool that we're going to use for this virtual fieldwork experience is a software tool created by Esri, the company that makes ArcGIS. So our driving question that we thought would be interesting for students is, why is it that you find marine fossils, sand dollars, in fact, in the middle of the desert? That is a very strange thing. And the audiences for this VFE could be any of several. The general public are welcome to visit, but in order to give us some focus, we chose high school earth science teachers or high school earth science classes. It could be that maybe it's a little more appropriate in some respects for an introductory college class. And each of these virtual field experiences has 5 modules. And in a module, in our case, means that it's sort of a highlighted topic. I mean, you can get a sense for it just by looking at what the categories are. We have one that really focuses in on the sediments at the sites, one that on the fossils, geology, so on. Okay, so I'm going to get out of the PowerPoint for a moment and go to the story map that we created. So story maps are tools, is a kind of tool made by this company called Esri. It's actually free, so if you find it interesting, you can use it, although it's like so many kinds of free software, what you can do with it is limited if you don't pay for it. And so I'm just going to take the time to click through how to get to where I'm going to show you in case you are interested. So here's Earth at Home. Notice that we have these virtual field virtual components, fieldwork, labs, collections. I'm going to go to virtual fieldwork here. And then here are the gold bars that you saw in the slide, and the case examples at the bottom. And then here's a short list of some of the ones that we highlighted. And I'm going to be going to the one that says the Kettleman Hills of Central California. And that is, I guess I probably don't have to scroll all the way down, but this is the one that I'll be describing briefly. And so if I were to click on here, it would take me to the Berkeley site. So here is our EPIC virtual field experiences site. And each of these localities here is or will be a virtual field experience. So Central California is the one that I'm referring to. And here is the sand dollar that we just looked at. The module I'm most familiar with, because I was involved in making this one, is the Explore Sediments one. But it's not necessarily the best one, I can assure you, but it's the one that I happen to know the most about. And then as you get into the site here, you'll notice that you can scroll. And as you scroll, you'll get content associated with different images. And I won't scroll all the way down, but I do want to point out this one image here, which shows this funny looking camera in front of an outcrop. You might be asking, well, how is this really any different than any other website that has pictures and text? And so I'll show you one aspect of that now. This camera can take hundreds of images and then with the special software, stitch them together into one very high resolution image. And so you'll notice along the left-hand side here, this text, there are various links. So I'm going to use this link here, but I have already got it loaded. So I will go directly to that link, but I just want to show you, this is what we're going to see. And here is that outcrop. But what's cool about it, and now for some of you, this might be old hat, but I still am kind of blown away by it, even after years of having used it, is that, okay, so imagine that you're standing here looking at this outcrop. Now, if you're a geologist, what would you do? Well, every geologist might be a little different, but I think typically a geologist would stand back, kind of look over the the texture and pattern of the whole outcrop, and then you'd walk up and look at specific parts of it, maybe specific layers. So I can zoom in on this, and notice I can zoom in and zoom in and zoom in to the point that I can see individual sand grains and individual fossils. Of course, I can't pull them out of the wall. That's the primary limitation. I can't actually collect a sample here, but it does enable me to follow these features along the outcrop. And in this sense, you can better create an experience for someone to feel like they're doing geology. I shouldn't say feel like, to actually do some kind of geology. So I have undergraduates who do this activity every year, and I give them a series of questions where they have to pick out a feature and they zoom in and they interpret what they're seeing. It's unfortunate that I can't bring them out to Central California, but it's pretty cool that I can bring them here. This is just one example of many different ways of creating a kind of visually rich experience that goes beyond individual photographs or perhaps maybe just a video that one would watch. So I see there, I'm just looking at the chat. Different mobility. Oh yeah, that's a very good point. Different mobilities. It also, obviously not everybody can get out to outcrops easily. Even if you lived in Central California, you might not be able to easily go up and down the hills and so on. So this does create a kind of window that wouldn't otherwise be available. So that's the general idea behind these virtual field experiences. So I'll go back to my slides here. Now there is, of course, you might say, well, okay, that's cool, but what if you're an educator? Would you know what to do necessarily if you weren't already a geologist? Well, okay, so we have a link here that says for educators. And if you go click on this link, it takes you to some activities, for each of the modules in several different formats. And there's a guide for the teachers and a guide for the students. And so I wouldn't say that there's anything particularly revolutionary about these. Here's the guide for the teachers. And of course, they have the expected next generation science standards. Okay, before I go to that, I'm going to go back for a minute to here. So here's the activity that we created for the students. Again, there's nothing revolutionary about this. I'm sure it could be improved in many different ways, and I'd be happy to know what they are. But anyway, we ask the students to go through a series of steps, and then this simply asks the students to draw what they're seeing and to interpret what they're seeing and so on. And the teacher guide then helps the teachers to think about what are the problems that the students might be having, what misconceptions might they be bringing to the activity, how might you have a discussion, and so on. Okay. I'm going to head back now to my PowerPoint and this ugly picture. I know this is probably almost impossible to interpret. So this is, at the top here, is this original kind of two-dimensional environment of every kind of VFE from passive to active and low-tech to high-tech. But what's missing here is actually doing science, right? I mean, of course, some of these things, well, maybe with the exception of the Mars rover, but all of these things are doing activities for which a student might assume, well, we already know the answer, and I'm just trying to figure out what is already known. But what we really want, another way that we would like to immerse students in field experiences is what it's like to do research in the field. So this next project is all about that piece. It's kind of an experiment for me and Don to go into the field with our colleagues and document what they're doing with photos and videos. There isn't a lot of revolutionary technology in what we're doing, but the idea is to document the process kind of from start to finish, but especially in the field. Again, this isn't a completely new idea. I think we probably all talk to our students about this process, but it is an attempt to try to humanize it and maybe extend what we might normally do, which would be perhaps just to kind of talk about what somebody does as opposed to kind of drop them into that world. All right. Okay, so so here we are again at the Cretaceous-Paleogene boundary. Now, in case you're wondering what the heck is the Cretaceous-Paleogene boundary, this is an image of the geologic time scale. You can also get this at Earth at Home, by the way. This is the single most visited page, I think by double, of any other page on Earth at Home, which is interesting. This was developed, of course, you can get geologic time scales in probably thousands of different websites, but John Hendricks made this visually very appealing version of it. You might have heard of the Cretaceous Tertiary boundary. So the Tertiary is a geologic period that geologists now split into two, into the Paleogene and Neogene. So now it is the Cretaceous-Paleogene boundary. It is a bit more of a mouthful. And then if we want to talk about what happens right in between these two, we talk about the boundary, we often abbreviate that to be the KPG boundary. Again, it's not really the nicest shortening. KT was rolled off the tongue a little bit better. But if you hear me say KPG, that's what I mean. Or if I wrote it someplace, I tend to kind of use these different things interchangeably. And my apologies if that's confusing. Okay, so let's dive into this process. About 5 years ago, a group of colleagues, some of them at the Paleontological Research Institution where Don and I work, got to talking about a proposal to study what happens at some sites across the Cretaceous-Paleogene boundary, in particular, what happens to the marine invertebrates in Mississippi and some other states in that area known as the Gulf Coastal Plain. And of course, you might say, wait a second, haven't people been studying that for over 100 years? What could they possibly learn, especially there? Haven't people been there? But on the other hand, if you've done research, you'll know that often we don't know nearly as much as you might think, and the world's a big place, and some of the sites that were studied previously haven't been studied for a long time, and there are some new sites that we didn't know about before. There's new technology and new analytics and so on. So this team of people decided that they would get together to write a proposal and work on this project. And it's important that it be a team because one of the things that's essential in modern paleontology, probably in almost any kind of modern science, is there's just too much data to collect, too many different kinds of things that need to be known for any one person to do it by themselves. Oops, I'm sorry. Hi. Okay, so long story short, 2019, you can see a smaller group on the left side. This guy here is Warren Ullman. Some of you may know him. He is the director of PRI. Two of these people were previously PRI staff. This is Corey Myers over on the other side of the table. She is at the University of New Mexico. She was a Cornell undergraduate who became Warren's assistant after she graduated and then went on to graduate school, now is a famous paleontologist. With her back to us here is Carly Peach. She was also a Cornell undergraduate, did a postdoc with Warren, and is now at the University of California at San Jose, also a rising star in paleontology. And then these other folks are, other staff also well known in the field. On the right side here is a group from, I think, a meeting about a year ago. You can see that the number of people around the table has increased, which is awesome. Some of them are students and graduate students, and this year the meeting table was even bigger. So I think the project is going great, but it's still very much in the process. There are very few papers that have come out yet. This is still really something in process. And so I put this slide here just to say that there are a ton of people involved. I'm sure this isn't even all of them, but these are the people that have been in the field with and or have seen otherwise at meetings. And so their faces show up in these pictures and they have graciously allowed that to happen. Okay, so what is it that these researchers wanted to do? I'm sure I could have boiled this down a little bit more. I de-jargonized it a little bit, but it's still a little bit heavy on the words. Okay, so they want to use stratigraphic sections. That means, stratigraphic sections are layers of strata of, rocks from different time intervals in the Gulf coastal plain. So I'll tell you about the coastal plain in a moment, but it's basically along the Gulf Coast, as you would have guessed. Not too far from the crater where the asteroid hit. You've all, I'm sure, heard about the asteroid that hit the Earth and caused that extinction. And so they want to use some new techniques and some new data from these new localities to get at what survived this boundary, which mollusks in particular. Mollusks are among the most abundant and best preserved fossils that we can get from the marine environment. It's a great record of them along the Gulf Coast. One might ask, how did anything survive that? And then rediversify after the boundary. So we know a lot about that, but there are many groups and species that haven't been studied in detail. And then more specifically, what is it that enabled some of them to survive? Was it, did they find suitable habitat? Were they able to adapt to changing habitats after the boundary? What exactly happened that enabled some to survive and many to go, and that caused many to go extinct? And then, of course, how did that influence the mollusk fauna that we see for the rest of the Cenozoic, including today? And so for students, we would simplify that and we just want to say, well, how did some of these sea creatures survive when the dinosaurs were killed off? And then, we'll be targeting this VFE in part to students in the Gulf Coast area. What is it that makes that area so special? Every place has interesting geology, but the Gulf Coast is really special for studying this particular question. If you want to know more about what it is that Carly and Corey, who are the two lead scientists on this, these are the two women that I mentioned who were at the table with Warren. If you want to know more about their work that's told in I think a fairly general level, with a little bit of technical language, they gave a really great talk that is available on YouTube for WSKG, which is our local Binghamton television station. Okay, very briefly, this is a geologic map of the United States. A geologic map if you're not familiar, is a map that shows the ages of different, the rocks of different ages at the surface. So for example, if you're from upstate New York, you'll recognize this broad kind of purplish blue here represents rocks of the Devonian period. There's a lot of them. They're very well preserved. In our area, we're famous for our Devonian rocks, and that is the subject of the current temporary exhibit. And on the other hand, in this area, below this black line here, which is known, this whole area is known as the Gulf Coast, the coastal plain. We have Cretaceous and Paleogene and Neogene sediments. And I see that I need to change my label on that. I believe that the yellow includes Neogene. Anyway, with that technical detail, so what's special about the coastal plain? It is an area of relatively low elevation that used to be covered more than it is now by seawater. So so this land was either lower and sea level was higher, so that it encroached well into our continent. Now, of course, you may have seen some maps of what the world would look like if all the glaciers of Antarctica were to melt. Horrifying idea, but you'll notice that that map looks a little bit like this for this very reason. So imagine a world without polar glaciers, or not many. It would cover a big part of what is now the southeast. And so where the continent was covered in the Cretaceous and the early Cenozoic era, sediments accumulated. And there were lots of critters living in the sea bottom and in the ocean, and they settled at the bottom, became fossils. And now that that is land, those sediments have become layers that are very fossil rich and provide an outstanding opportunity for us to understand something about the history of the marine environment in that region. And the place where you have to think, well, where would I look if I wanted to see what happened precisely at the Cretaceous-Paleogene boundary? Well, you would look at the boundary between the green and the orange colors. And in fact, there are a series of sites along this boundary. So if you ever wondered, how do geologists know where to go to find certain fossils? Well, okay, sometimes there's some luck involved, but they also have geologic maps for the entire world to tell them at least something about the age of the rocks, and sometimes we know something already about the environment of those rocks that we expect to find when we go there. And so this is probably the most technical diagram that I'll show you, but here is that region, right? So Mississippi, Louisiana, Alabama, and here in this band here are some of the sites that I'll be talking about. Mississippi, and Alabama. There's sites in Arkansas, even up into Missouri. You don't see them on this diagram, but on this diagram on the left, which shows a slightly broader area, we can even see sites that are in Texas. Now you might think, wait a second, I don't see Texas on there. So if you look very carefully, this dotted line here is the current coastline. Well, what's this line then? Well, this is the coastline in the late Cretaceous period. And so all of these areas were underwater. And all of these little dots are sites on land now where we can find sediments that were deposited underwater in the late Cretaceous period and first part of the Paleogene. And so I mentioned this in part because it is these little dots here that will be the sites that are in the VFE. And also over here are some sites in Texas that are very important. Okay, so let's finally, I promise we're getting to the VFE and almost to the end of the talk. So I created a story map for this. Actually, I exaggerate. Richard and Elena, my interns, created a story map. And together we created the text that tells the story. Now, before I go any further, I'm just going to go to that story map. Okay, let's see here. Okay. Now, your first thought might be, okay, so how are we going to take this probably pretty technical research and make it accessible to um, students and the general public who may not be familiar with any of this terminology, or at least not very much. So the first thing that we had to think about was how do we give the backstory in a way that's engaging and fills in that background information that makes visiting the field sites meaningful. And that's really where we've spent most of our time up until now. So this story map contains a description of what happens at the Cretaceous Paleogene boundary, especially in the marine environments. And tells about Mississippi in particular, with the idea that students in that region might find that especially interesting, and what happened at the boundary. Okay, so I'll stop there for a moment. You're all familiar with the idea that the dinosaurs are extinct, except for the birds. Okay, what happened? I think you've all heard of the asteroid impact. You might have heard of other ideas as well. I'll just tell you that the consensus view among people that do this kind of work is that it is absolutely the case, even though it sounds like a tabloid story, that an asteroid did hit the Earth about 66 million years ago, creating essentially a global ecologic disaster. And it did a bunch of different things, but among the things that it did was throw dust up into the atmosphere that would have blocked out light, cooled the atmosphere, possibly created some other kinds of atmospheric toxicity, essentially. But not everything went extinct, of course, and that's part of what we're interested in. And we're interested in part about, in these so-called mass extinctions because we have big extinctions going on now, and we want to know what kinds of things tend to be resilient or how can we help them be resilient. Anyway, there are some other ideas about other factors that may have played a role. A lot of volcanism in India at around that time and so on. And I think the current consensus is that none of those other things actually were the trigger that caused the extinction, but they may have played some role if they were already stressing kind of the global ecosystem in some way. Okay, so there's the deadly strike. And then some information about, what can we learn? I know I'm just scrolling through text, so there's nothing really to see here. But then we get to the 4 Mississippi research sites. And this is where we get to the reason that we're doing this. So here is a site. I think Elena Brion may have originally created this part of it. This is a map that contains these little radio buttons, and each one of these buttons corresponds to a little card over on the left side here. And so we are highlighting 4 of these sites in Mississippi. So the 4 sites are significant for their importance to the research. They are also the ones that Don and I got to visit. I mean, it wasn't an accident that we went to these 4, but they are the ones for which we have lots and lots of pictures and video because we went there for this purpose. And then if we click on one of these, let's say I click on Ellis Sandpit. And so I'm waiting for that to load. Okay, here's Ellis Sandpit. Here's Warren. I believe this is his assistant Kira in the background. This does not look like much. There's not a lot of elevation in this area. And so to find outcrops, you have to go to places like little creeks where the outcrops appear. Okay, so what's the big deal about this site? Well, what we did is we took videos and pictures of people discovering stuff as they were doing it. So I'm just going to show you a few of these because I think they're fun and I think we have time for it. So here, for example, let's see, I'm going to stop sharing for just a moment because I have to click a button that says to share my audio because I want you to hear what people are saying. All right. Share screen, share sound, optimize for video. Okay.
This is a fish jaw. This is a fish jaw right here.
It's a big fish too.
And this is really diagnostic. This is ringing a bell.
That's what caught my eye.
Yeah, the serrations, yeah, along the edge there. But it's got at least one tooth in place, maybe more. So I will probably GPS this and let one of my vertebrate enthusiasts.
So I'm not quite sure. This worked in practice. So
we could hear the audio and see a still image.
That's
so
great.
That was
All right, so
interesting.
there's not a lot of stuff to see, but we should.
This is a fish jaw. This is a fish jaw right here.
It's a big fish too.
And this is really diagnostic. This is ringing a bell.
That's what caught my eye.
Yeah, the serrations, yeah, along the edge there. But it's got at least one tooth in place, maybe more. So I will probably GPS this and let one of my vertebrate enthusiasts that help me in the field a lot come dig it up, unless you guys want to try and do it. Okay.
Okay, so they're just little clips. So this next one, well, okay, so I have to give you a little bit of background. There are a finite number of sites of the Cretaceous Paleogene boundary. I mean, that is one of the problems, is that we can't, it's not like working out west where there's no vegetation and you can follow a boundary for miles or something. This, you have to take what you can get. And so when you find a new site, it's very exciting. So we were at this place where you just saw the fish jaw. And this guy, George Phillips, who's from the Mississippi Natural History Museum, it's wonderful, went out and helped us look and identify things and so on. He just went over this little hill to kind of check out what else was at this place. Well, there'd been a lot of rain recently, and that had actually been a real hassle doing rain in the summer in Mississippi with, pouring and so on. So it's not a great thing, it's creeks overflowing. But in this particular case, it had caused a small creek to cut a channel through some sediments, exposing a new boundary. And so this is George. He thinks maybe he's found this like new site, and this is him talking about it.
Yep. Yeah, they are hollow.
Oh, they're gonna be so big.
Yeah. So some of them are pretty big. So you'll see a combination of objects and voids left by the objects.
Okay, so I have to explain what he's showing here. So imagine that the asteroid hits, it basically vaporizes all of this rock up into the atmosphere, which then condenses into little rock droplets. I hope I'm explaining that correctly. And then, so the little droplets cool immediately into little glass beads, tiny little, like little BBs, and fall to the ground. And they're one of the kinds of evidence that, this really happened. And they occur across a very broad area. And they are kind of a smoking gun for that, oh, this is the boundary. So here's George like saying, this is it.
Now we call them spherules, but some of them are oblong. But most of them are spheroidal, roughly spheroidal. And some of these in here look like they're upwards of 1 millimeter and to 1.5 to 2 millimeters. But they look like little eggs because their shell is breaking away, leaving a void. So you Can you kind of see that? Can you zoom in and look at little round voids in the matrix? So those are the spherules, but you're seeing remnants of the surface of the spherules. And the anatomy of these spherules has been studied. These altered spherules, which were originally glass, and what we're seeing them here, we're seeing some kind of iron hydroxide after the clay. And then they decompose to a clay, a type of smectite called non-tronite clay.
So anyway, he starts to get kind of technical there. But I just love that little clip because it caught him in the act of like finding this thing and being excited about it. And then the other thing, of course, that we can do if we're actually documenting the research is document people doing stuff that has to be done, which is, of course, not all glorious finding T-Rex bones. Here is Corey Myers digging out a trench. Notice this is very different than digging in the hard rocks of like the Devonian. This is slightly lithified, but most easy to break apart with a pickaxe.
Look at how the boundary is so much easier to see, right?
Yeah. And this is our designated flat.
This is doing geology.
That's your wax dye. This is my wax.
Oh, okay. Well, I'm not gonna wax anything.
Okay, I'll stop that there. You get the idea. So we have lots and lots of these videos of people doing stuff, measuring sections, so my goal with this is to include all of those. We have a few of them already in the BFE, but we're still working on that. Now, I'm just going to go back to see. I think I have a couple slides left. Oh yeah. So, to finish off, here's a site called Owl Creek, famous site for studying the boundary, actually for over a century. And look at what you have to do field work here. You have to walk through this creek. We have video of doing that. And then in order to climb the cliffs, you have to use your pickaxe to dig out these little holes. And you can see these little holes here. So, you can use your pickaxe to sample the layers as well, but that's what you use to climb up the cliffs. And then this is the kind of stuff that people are finding. You may or may not think that that's spectacular, but it's very cool while you're there, especially when you're with people who know what it is and understand the significance. We all tell our students how important it is to take field notes and use your hand lens and so on. Well, they may, it's not that they don't believe us, but here's a situation where field professionals are doing those things because they need to do them. And no one's asking them to do it. It's because it's useful. So I think it might be useful to just document people actually going about their business using these kind of ordinary tools. This is bagging up the samples. Again, it is not spectacular work. These are so-called bulk samples on the left side, carrying back lots of sediment. And here's, somebody's job is to sit and wrap fossils in paper towels and masking tape, and then to label each one of them and put that in their field notebook. And you can see that there's this whole assembly line here. This is work that people do together to have this larger goal. Again, something that may not come across even when we do group work, because students don't necessarily see their own teachers and professors doing that work. This is what I just talking about. We have some videos of people, making measured sections and sampling the fossils and so on. We had a wonderful variety of people from all over the country. You can see some of them are old white guys, but a lot of them are not. And there's lots of young people and a lot of women and a little bit of, some ethnic diversity. And so a really nice variety of people from all over the country. And so, we were just taking pictures in the field. It just shows people working together to get things done. I think maybe I'm going to show one more video clip. I think I'm pretty much at the end of my time. But I think Corey says this well in a little video clip of her. I think it's this one here.
One of the things that's been really fun for me on this project, I've visited a fair number of KPG boundary sites. I've done this sort of field collecting before, but this is a new group of folks for me to collaborate with. And we have so many different students in this project from so many different universities. It's great to be able to meet people at different stages of their career and see what inspires them and what they get excited about. I have a lot of students that think that science is not a team sport, and that science is done sort of by some guy in a lab coat in a cold, sterile building, and that couldn't be farther from the truth. A lot of paleontology is done collaboratively like this, and I think we all learn a lot more, and we're all a lot more successful when we're working together like this.
Called over here or there, you leave it, and then you're like.
Okay. So the last part of this, the finishing up the VFE, in addition to doing a lot of video editing and so on, is going to be telling the story of what happens after the field. So, of course, packing up the specimens and sending all of these are boxes being shipped back to laboratories, actually studying them. This is a cross-section of a big oyster for isotopes. Neil Landman is a famous Ammonite paleontologist at the American Museum of Natural History. They're going to museum collections to look at more material. And of course, then showing up at conferences and giving talks and sharing with colleagues what was learned. So I'm actually in the process of trying to figure out, okay, what do students do with this? Is it an activity where they use some pictures from the field to make a stratigraphic section? Or should it be something different along the lines of imagining that they could go out and do this, and maybe that they could discover a new field site? And if they did that, what would they do to create this kind of experience? They would need to get permission, they'd need to plan to do the field work, fund their work, figure out what to look for, and so on. So I'm actually in the process of trying to figure out what the assignment looks like. I would be very grateful for suggestions. And with that, I will stop sharing. And then I can look at the chat box more easily. Okay, so I'm going to very quickly look through the chat box. Rob, can you provide a link to the story map? Yeah, I can do that. I'm going to do that now. And like I said, this is a work in progress. Like I published it in quotes. That's what it's called when you make it available for other people to see. We haven't suggested that anybody use it yet because it's still like half done. However, you are welcome to use whatever's there and to make suggestions. So let me put, oops, okay, KPG story map. Okay, any questions or suggestions? Kip, I like your photograph. Thanks, Patrick. Any other thoughts?
Hey, Robert, this is Wendy Williams.
Wendy.
I know Don, I've worked with him for a long time on committees through NAGT advocacy. So I really like what you were sharing here, and I want you to know my mind's just spinning. I work for a large community college district on the US-Mexico border out of McAllen, Lower Rio Grande Valley on the Gulf of Mexico coast
Oh.
area, right? So the students get really thrilled because of also the cultural significance of current geography. This is in their backyard, right? So yeah, I'm already thinking, all right, how am I going to update my freshman core level lab science class to immerse some of this stuff into the historical geology and the physical geology? So thank you.
Yeah, great. And
I've
please,
got dual credit in traditionally and non-traditional age college students. So
that's amazing. Yeah, and there's a lot more. I showed you Mississippi. There's a
yeah,
lot of footage from Texas. That whole region obviously is important. So yeah, please be in touch, and I'd be happy to tailor things or take your suggestions to fit your needs.
well, thank you. Thank you so much.
Well, thanks everybody for showing
Hey,
up.
Rob, I just had a quick question.
Yeah.
I just wanted to know, hi, it's Patrick here. You've been really helpful with me for the past year. I've actually talked to you quite a bit.
Yeah.
I just wanted to know really quickly, like if you had any like layers or anything to see that stratigraphy in, like the actual images yourself. We're able to zoom in really quick and like see all the layers and the fossils, but is there anything like a filter for somebody who might like find it difficult to see that changes and stuff? I think
That's
that would be a really cool idea or something if
Hmm.
that was visible when you were able to check it out.
That's a great idea, Patrick. So I'm sure there are graphic ways to kind of point things like that out, where like one could be able to put a layer over or remove something, so that you could kind of get your eye into it. You're absolutely right. I think that's one of the challenges, especially when you're first learning about going into the field, being able to know what to look for and actually knowing what to filter out is incredibly challenging.
Yeah.
And everything seems important. And when everything seems important, then nothing, you don't know what to prioritize. And it is, I mean, the fact is that it can be challenging even for people that do this for a living sometimes to figure out, okay, where exactly am I? But that's a good idea. We'll think about that.
Thanks again. Cheers.
Yeah. Take care. We'll see you, Patrick. See you next field season. All right. Shall I let y'all go? All right. Thank you. Thanks for sticking with me for such a long time.
Good night, everybody.
Good night.
Good night.
Good night, and thanks.
Yep.
And it's wonderful your sister was supporting you.
Yes.
Very nice.
It was quite fun for me. Thank you.
I think that's lovely. Good night.